In part 2, in our lesson on the trigonometric functions, we're going to study how you can use different points on the terminal side of theta to find the trig function values. So in this example, we're going to find sine theta, cosine theta, and tangent theta using the point 4, 3. We can see that the terminal side of theta goes through this point, 4, 3. And if we use the point 4, 3, we know r would equal the square root of our x-coordinate, 4 squared, plus our y-coordinate, 3 squared, which is the square root of 16 plus 9, which of course is the square root of 25, which is 5. So now we know that x is 4, y is 3, and r is equal to 5. So now we can evaluate the trig functions. Sine of theta we know is y over r, so that would be 3 over 5. Cosine of theta is x over r, so that's going to be 4 over 5. And tangent of theta is y over x, which is equal to 3 over 4. So now we're going to find another point that lies along the terminal side of theta. And if we extend this ray out, probably the easiest point to find would be making use of the slope. We know we're going to have a slope of 3/4, which means we could go up by 3 and to the right by 4, which means we would land on the point 8, 6. So let's use this point to find the trig function values. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. R would then be the square root of 8 squared plus 6 squared, which is the square root of 64 plus 36, which is equal to the square root of 100, which is 10. So now if we find the trig function values, we've got sine of theta is equal to y over r, which we know would be 6 over 10, which reduces to 3/5. And you notice that that is exactly the same value that we had using the point 4, 3. Cosine theta is equal to x over r, so that's going to be 8 over 10, which reduces to 4/5, same value that we had before. And finally, tangent of theta is equal to y over x, which is equal to 6 over 8, which reduces to 3/4. And once again, we get the same value that we got before. So the conclusion here is that you can use any point on the terminal side of theta to find the trig function values. In this example, we're given that the terminal side of theta is defined by 3x minus 2y is equal to 0, with x being less than or equal to 0. Now remember, from our pre-trig review, this is the equation of a ray. We know this would be a line all by itself, but with this part, that x has to be less than or equal to 0, that turns the equation of the line into the equation of a ray. Now, probably the easiest way to graph the ray would be to put it into slope-intercept form. So we want to get the y by itself. So we would have negative 2y is equal to negative 3x. Divide both sides by negative 2, and we have y is negative 3 over negative 2 times x, or y is equal to 3/2 x. Now remember, we have to pick x values that are less than or equal to 0. Now we know that the ray is going to go through the point 0, 0, because if we put in a 0 for x, we're going to get 0 for y. Now we want to pick x values that are easy to plug in. We see we have a 2 in the denominator here, so we might as well pick x values that are multiples of 2. And again, we have to remember to pick an x value that is less than 0, so I'm going to choose x to be negative 2. Then the y value is just going to be 3/2 times negative 2, which is negative 3. So that means we're going to have the point negative 2, negative 3 on the ray. So now we can come on over here. We know our ray goes through 0, 0, and we know it goes through negative 2, negative 3. So we can plot that point. And this would be theta. Now we have to find the 6 trig function values, so we know we need to find r. R is going to be the square root of x squared plus y squared, which is going to be the square root of negative 2 squared plus negative 3 squared. So we have the square root of 4 plus 9, which is radical 13. So we know r is going to be the square root of 13. So we have x, we have y, and we have r, so we're ready to find all 6 trig function values of theta. Sine of theta we know is y over r, so it will be negative 3 over the square root of 13, and we do have to rationalize, so we're going to multiply by 1 in the form of radical 13 over radical 13, and we get that sine of theta is negative 3 radical 13 over 13. Cosine of theta we know is x over r, so that's going to be negative 2 over radical 13. We're going to need to rationalize that, multiply by 1 in the form of rad 13 over rad 13, and we get that cosine of theta will be negative 2 radical 13 over 13. Tangent of theta is going to be y over x. So our y value is negative 3. Our x value is negative 2, and of course a negative divided by a negative becomes a positive, 3 over 2. Cosecant of theta we know is defined to be r over y. So r is radical 13 and our y value is negative 3. Secant of theta is defined to be r over x. So we'll have radical 13 divided by negative 2. And finally, cotangent of theta is equal to x over y. So we're going to get negative 2 over negative 3, which becomes 2/3. So there's our 6 trig function values of theta.